Hey guys, welcome to codedecode. In this video, we are going to look into some very important Kafka interview questions. Also, please do like, share and subscribe to support us so that this ranks better with the YouTube algorithm and reaches to more of the people who are preparing for interviews just like you. Let's get started. What is Apache Kafka? So Apache Kafka is a publish-subscribe model which is based on durable messaging system. So basically when you have to do some asynchronous communication between different applications where you have multiple producers producing to your topic and multiple consumers consuming from that topic, then you have a publish-subscribe model required. Also, it needs to be durable enough because if your consumers die, then the data that is on the topic should not be removed. That should be durable enough. Also, when you have multiple consumers, they will be subscribing to your topic. So one consumer when consuming your message should not remove the content or the message from the topic. Thus, to make it more subscribable to more consumers, it has to be durable. So what Kafka do is they make the message persisted on the Kafka topic and each message has some time to live. So that after that time which is expiring, then only the message has to be removed from the topic. Till then, any number of consumers can consume that message who is subscribed to that particular topic. So that is why it is said as publish-subscribe model. The producers publish to the particular Kafka topic and multiple consumers subscribe to that particular topic to get the messages from that topic. And since it is not removing the message after one of the consumers read it, it is keeping it alive till the time to live is not expiring. That is durable messaging system. So Apache Kafka is a publish-subscribe model with a durable messaging system which helps in exchanging the data between multiple applications, processes and servers. Basically, we do it between multiple microservices, then those becomes the backend applications or processes. Now, Kafka was initially created by LinkedIn people, was written in Scala and Java, but later on it became open source in 2011 and now it is a very important part of Confluent Stream platform, which is handling millions and managing millions and trillions of data events daily. Many well-known companies use Apache Kafka nowadays for both handling the logs for streaming and also for sending the data from one application to another using it as a asynchronous medium of communication. So in real time, the management of data and logs is a very tedious task which involves processing, reprocessing, analyzing and handling multiple information. So that's where the Kafka comes into picture. It plays a very significant role in handling your messages and handle the messages from multiple producers and sending it to multiple consumers. Also, it helps in the streaming environment where you have multiple of logs, which is very much time specific. So for example, at 11 o'clock night, there is one log coming. At 11:01, there is another log coming. At 11 o'clock, 2 minutes, there is third log coming. Then it has to be in particular sequence and order. That's where also Kafka comes into picture. So to handle large volume of data and in a particular order, that's also where the Kafka comes into picture. So you can use Kafka in two ways: for handling the messaging between multiple applications and for handling your logs and showing it on your logging tools like Splunk. There you can show all your logs which is captured by Kafka and hence will be very effective in streaming environment. Hey guys, recently we have launched a course covering an end-to-end full stack application using Angular as front end and microservices and Spring Boot as the back end. Also, we have used cloud to deploy this application and we have used CICD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is REST-RESTful web services, Spring Boot and microservices for backend, Angular for front end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka server and all those microservices counterparts. Now this is the CICD pipeline. This is the CICD flowchart for the application that we have created on local. So this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline and do the CICD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links. Now, what is the architecture of Kafka? Is a complete playlist where we have implemented Kafka in one of the application and we have seen how Kafka actually works. But just for the complete overview, again for this video, we'll be seeing the architecture of Kafka. So Kafka basically consists of one big cluster. There are multiple producers, there are multiple consumers. These topics resides in brokers and brokers resides in clusters. So there is one big cluster. In the cluster, there are multiple brokers. The Kafka is made to be fault tolerant. And to make it fault tolerant, it has to have the data replication. That means if you are writing some data to one topic, that data is replicated multiple times in the cluster of Kafka so that if your topic or the broker dies, your data is still there at some place in the disk in another broker or called as follower broker. So there is one leader broker where the producer writes your data and there are multiple follower brokers who are going to replicate the same data that you're going to write to the topic. So that's why there's usually said at least minimum of 3 brokers should be there, where one will be the leader broker and 2 will be the follower brokers, so that you have twice the data replication. And hence whenever there is data failure for broker 1, you will have your data persisted twice in the disk space. So usually the clusters have minimum of 3 brokers. These brokers are nothing but the Kafka servers. So remember when we were coding, we have 2 servers, the Zookeeper server and the Kafka server. The Kafka server is this broker. There is one big cluster. There is one leader broker and multiple follower brokers. Each broker consists of multiple topics. So one cluster have multiple brokers. So there is one to many mapping like this. So one cluster has multiple brokers. Now each broker will have multiple topics. So one broker is capable enough to host multiple topics where producer can write and consumer can consume from. Now each topic contains multiple partitions. So these are multiple partitions, partition 1, partition 2, partition 3 and so on. These partitions are the place where the data is written. Now these partitions have multiple offsets. So what are offsets? Offsets are just the unique ID each message is given to. So you have 3 logs coming at 11 o'clock, at 11:01, at 11:02. So these 3 logs will be at offset 1, offset 2 and offset 3 in the partition in this particular order. So whenever a consumer reads from this partition, it will always read in sequence, that like offset 1, it will read the log of 11 o'clock. At offset 2 in the partition, it will read the second log which is coming at 11:02. And in the same partition, at the third offset, it will read the third log. So it will read in the order. And once it has read the complete batch of offsets, it will acknowledge to Kafka that yes, I have consumed your 3 offsets and I'm going to commit my offset as 3. So if the consumer 1 dies, then it can start from the 4th offset because 3 offsets are already read before dying. So that's why marking the offset and acknowledgement to Kafka is very important. So basically the producer is going to produce the message. The message is going to be stored in partitions which resides in topic in a particular broker, in a particular order which is marked by this offset. So basically your one cluster contains multiple brokers with one leader, multiple follower. Each broker hosts multiple topics. Each topic consists of multiple partitions, and in the partition the real data lies in a particular order marked with an offset unique ID. Now how do you know that producer has to write to which partition? It's a very important question. So a producer uses this producer record instance. So there it says which topic it has to write to. So the topic name it gives in the argument. Also it gives which partition it has to write. Remember, this is optional. The partition to which the record has to be sent is specified. If it is not specified, then the default partition key is used to define the partition which is empty and which is capable enough to handle your data. So that is how it decides which topic. Now you know that there is only one leader. So producer knows this is the only leader, so I have to write it to this leader only. So suppose broker 1 is the leader. Now it knows that yes, since broker 1 is the only leader, I'll write it to this broker. The second is which topic. So it gives this information in the argument. Then to which particular partition it has to write. Either it will give it in the argument again, and if it doesn't give in the argument, then default partition key is assigned, and based on that partition key which producer is sending, the partition is decided by Kafka itself. Now, who decides the offset? So remember, Kafka has the offset management into it. So it knows that its 3 offsets are full. Now, the producer's message will be written from the 4th offset only. So the offset management is done by Kafka. Rest everything producer can decide. So producer can decide which topic it has to send and which partition it has to send. But since there is only one leader, it will be going to only first broker. And also, since the offset management is done by Kafka, the next empty offset will be given as a place for producer 1 to keep its message. That's how producer puts the message to Kafka topic. Now, how consumer consumes it? So again, since you know that there is only one leader, consumer will read from broker 1 only. Now you also know that consumer always knows from which topic it has to read to. So again, consumer knows that it has to read from topic 1 from which partition. What it does is it reads from one particular partition. As soon as it starts reading from the partition, the offset is fetched. Offset 1 is fetched. That means the message 1 is fetched, which was coming at 11 o'clock. Offset 2 is fetched. So consumer pulls it basically. So when the second is fetched, it knows that it is at 11:1 p.m. Also, when the third offset is fetched, it is an orderly fashion, 11:2 p.m. Now, when it has read the complete batch of logs it has to read, what it does is it acknowledges the Kafka that yes, I have read it successfully. Now, once it do it, it also commits the offset. There are 2 important tasks the consumer do. That is, it acknowledges the Kafka that yes, I have successfully read your message. So each message it read, it acknowledges that I have read it. So that Kafka knows that yes, it has successfully read it. Also, once the batch is done, it commits its offset. And why does it commit the offset? Because it says that, okay, 3 messages I have read. Now, even if I die, then I know that I have already read 3 messages. I should not read it and make it duplicate reads. I should start from 4th location. So, this is also beautifully done by Kafka. Whenever consumer 1 comes back to its life, Kafka says, oh, you have initially committed your offset as 3. So that means you've already used the 3 logs. Now do not come and read it again. You do not have to read the log coming at 11 o'clock, 11:1 and 11:2. Now you start reading from 11:3 p.m. Consumers not only just acknowledges the each message it is reading, it also commits its offset that yes, I have read till this much. Now even if I die, if I come back, I should not read it duplicately. So that is why first of all the order is managed by Kafka with the offset management. Also, the duplicate message is not read again and again, and you do not see in Splunk that your logs are repeated. You never see that your logs are repeated in Splunk. Why? Because it knows that I have read till 3rd log. Now I have to read from 11:3 p.m. So that's the way the duplicacy is also prevented, and also the order is also managed. So for the high level overview, there is a cluster containing multiple brokers where only one is the leader, rest are followers. Also one important thing. This is the task of leader to make the rest of the followers copy the same data that producer has written. What the producer do? It writes the data to the leader in the partition. So always the data redundancy is done at partition level, because where do you think the data is actually written? The data is actually written in partition. So always the data is replicated in partition. Now this broker who is handling the leader partition is the leader broker. The one who is handling the follower partitions are the follower brokers. So now the partition 1 will be the copy in the broker 2 as partition 1 and broker 3 as partition 1 at some different disk location. So that whenever the broker 1 dies, suppose in case for any reason this particular server crashes. What is this broker 1? This is a server that we have started with some Kafka command, if you remember. For any case, you did the control C or you stopped that particular server. What will happen? Your data will be lost. Then what will happen is instantly the second broker or the third broker who are eligible enough, who are the proper followers, can become a leader. And who manages all this leadership management, all these management? The zookeeper is the one who manages the leader election and the Kafka cluster management. So that's why zookeeper is very important, and we have not just started the Kafka server, we have also started the zookeeper server since we were using Kafka 2. Also remember, with the upcoming Kafka versions, we are trying to remove the zookeeper dependency, because whenever we have to run the Kafka, we always have to run the zookeeper. We do not like this dependency, so they are trying to remove the dependency of zookeeper and trying to integrate it inside the Kafka itself with the management tools. So, but as of now, till Kafka 4, this is not yet ready. So, if you're using till Kafka 2 or below, then you have to start the zookeeper for sure. Your Kafka will not work without zookeeper, because it is the one who manages your clusters. Again, the cluster has multiple brokers, where there is one leader broker and rest are the followers, and it is a task of leader to make the followers write in the different disk space the same data. So, how leader will do that? It will maintain a log, and that log is read by multiple followers and they update themselves. Now, the leader broker also hosts the leader partition. Now, where is the data kept? In the partition. So, the one where the data is actually written is the leader partition, and the broker hosting that partition is the leader broker. Now, the leader partition is where the producer writes and also the consumer reads. Rest of the broker hosts the follower partitions and hence will replicate the same data to the different disk location for the fault tolerance. So if anything goes wrong with the leader broker and it dies, then that disk space might be lost. But the different brokers who are the followers will have the same data, because they are reading from the leader log, and hence they have the same data at different disk location which is still alive, and hence your consumer can still consume the same data the producer has written to your topic. And hence that's why I say Kafka is the very fault tolerant method of communication between different applications. Now let's see each and every component in detail. What is a producer? A producer is the one who publishes the messages to Kafka topic. Now they create a producer record like this, where it gives to which topic it has to write. So suppose there is an application, that is order application, which sends the email that order is successful or order is cancelled. So the order service will send a message to the email service, and the mode of communication will be Kafka. Then it will create a record with saying that please send to which topic. So email topic will be the topic to which it will send, and also email topic will be the one where consumer will be consuming, that is, your email service will be consuming. So there is a common topic named as email topic. The producer, that is the order service, will send to the same topic and consumer will consume the same topic, that is email topic, to send the email to the consumers. Now partition is completely optional. It will tell you at which particular partition you have to write. The offset will be decided by Kafka. The partition can still be decided by you, but it is still optional. Kafka says you can give the partition, I'll write it to there. If you still want that, no, I don't want to give a partition, write it anywhere. My consumer will read it, and the consumer offset management will be again done by Kafka. Then it will read the default partition key, decide which partition is less overloaded and will be written there. The key is actually the key associated with the message, which is used to determine which partition this message has to be sent. Now, if it is not specified, again Kafka will do it. The value is actually the content. So I want to send an email. So order is successful. So this order is successful value will be sent as a content or a message in this third attribute value. Now headers are just the collection of headers to be included with the message. This is just the metadata which is added with this value. Nothing much. So even that is optional. So what all things are optional? The partition is optional, the key is optional, and header is optional. But you have to tell which topic you have to write and what you have to write. At least this much you have to do. So that's why the topic name and the message that you want to write to the topic is compulsory. So that's how you create a record and you send it to the particular topic in a particular partition. The broker is always the leader broker, which is taken care for. The topic is what you are sending here. The partition can either you give or Kafka automatically decides which partition it's less loaded, and offset is always managed by Kafka. Next is the topic. Now what is a topic? A topic is actually the logical channel which categorizes to which messages are published. Now topic is divided into multiple partitions for scalability and parallelism. Now, if you have multiple messages coming, what it will do is it will increase the number of partitions to accommodate more and more of your logs. So that's why when you have more logs, it will increase the number of partitions, else it will remove them. So that's why you have horizontal scalability in the terms of partitions. Also parallelism, that is because multiple consumers can read from this particular partition. Remember, one consumer from one particular consumer group can read only from one partition. I'll cover consumer groups in the upcoming questions. We will see what is consumer group and why only one consumer can read from one partition. That is mainly because of order maintenance. Also, different consumers from different consumer groups can read from the same partition. That is also possible, but not from the same consumer group. The same consumer group, only one consumer can read from one particular partition. Now, what is partition? Each topic is divided into multiple partition, and this is where the actual data is kept. So partition is the basic place where your data is kept, and that is the place where replication happens. So partition is the one which replicates into multiple brokers. Now, what is broker? The brokers are the servers. Remember, we have started a Kafka server. This is the broker within a Kafka cluster. So what it does is it stores, manages, handles the data. It handles the producer and consumer request and participates in replication and distribution of data. So it's the task of leader broker to make the replica of the same data to multiple follower brokers also by maintaining a log. What it logs is, this is the message, it comes at this time and it does at this particular offset. You have to keep it in this particular partition so that all this information can be taken by another broker and just copy it. Now, what is Zookeeper? Without Zookeeper, the Kafka cannot work before 2.x.x. After 2.x.x, there's 3.6. something, which is now having some possibility of removing the Kafka dependency, but it is not yet production ready. But with Kafka 4, for sure, they will going to remove the Zookeeper dependency for Kafka. But before that, Zookeeper is the one who manages the complete cluster for Kafka, and hence Kafka cannot exist without Zookeeper. So Zookeeper is the one who coordinates and manages the Kafka cluster. And what Kafka cluster maintains? It maintains the complete data because it is the one who is handling all the brokers, partitions, topics, offsets, everything. So the main part of Kafka is Kafka cluster, and that is managed by Zookeeper. So you cannot work without Zookeeper at all before 2.x.x version of Kafka. It maintains the metadata, leader elections, and manages the overall state of the cluster. Also, when the leader broker dies, who decides from which follower the leader has to be chosen? Who does that? Zookeeper do that. Now, how is partition replication done for the topic? Now, each partition has multiple replica for fault tolerance. Now, these partitions are actually distributed across multiple brokers. Now, one partition is defined as leader partition and others are follower partitions. And the one broker who is handling the leader partition is the leader broker. And the one who is hosting the follower partition becomes the follower brokers. This is the only way to decide among the broker who is going to be the leader, who is going to be the follower. Now, consumer is the one who subscribes to the topic and consumes the messages. Each consumer group can have multiple consumers. Again, what's consumer group we'll be seeing in the upcoming questions. So consumer groups, the consumers are organized into multiple groups. Each group consists of set of partitions allowing for parallel processing and load distribution. So what happens is you have n number of logs coming at every minute, 11, 11.1, 11.2, 11.3. So you need to show it on Splunk, right? So who is going to consume? So consumer has to use the subscription to that particular topic and do it in parallel process so that you can read all the logs continuously and simultaneously. That task is done by consumers when they are running the log reading in parallel to increase the processing of data. And hence it is the Kafka is meant to be very good in streaming environment because multiple consumers can read simultaneously by dividing a group of consumers into consumer group. Now, offset management. Who does the offset management? Kafka does it for us. So offset represents the position of consumer within a partition. So that's the position where the consumer is reading. Now, since only one consumer can read from one partition, so whenever the consumer dies, it knows that it has to read from the place where it is left. That is also managed by Kafka for you. So internally Kafka does a lot of things for you that you don't know. But it is the reason the Kafka is maintaining the order and also maintaining the replica for you. So consumer's task is to acknowledge as soon as it reads the data, and also after a batch commits that it has read till this much point. Now even if I die, I'll read from the next offset so that no data duplication is there. Now log compaction is there, where only the latest message for each key in a partition is read. It is useful for scenarios where the latest state for the set of keys is crucial. There can be like at 11 o'clock 2 set of logs came. So only the last one is kept, the previous one is removed. So that's where log compaction is also done by Kafka for you. Now Kafka cannot work alone. It has to integrate with multiple systems like Splunk to show the logs to somewhere, right? So Kafka Connect is a framework for integrating Kafka with external systems to help the development of connectors for ingesting the data to and from the Kafka to the various sources and sinks. That is to various producers and consumers. Now Kafka Stream, that is again very important processing library that allows developers to build real-time applications and microservices using Kafka as an underlying infrastructure, so that you can use the logs coming from the backend application and show it to Splunk-like tools where the logs can be seen by the users. Now what's the complete flow? The producer writes to the leader, it sends to the leader partition, the leader appends this to the log. Now the task of leader is to write a log with a particular message coming at which particular time in which particular partition. Now the replication is always done at partition level. So what the leader will do is it will replicate the message to followers, and followers will make sure that they have same set of messages in their different disk space, so that replication is maintained. Also there is one more important term that is always asked in an interview, that is ISR. What is ISR? It is in-sync replica. What does that mean? In-sync replicas represents the follower partitions that are up to date with the leader partition. So in-sync replicas are the one who are capable enough to become the leader whenever the leader dies. So it's basically the replica, nothing else. It seems to be a very difficult term, but it is nothing but a replica which can become a leader whenever the leader dies. Now what is the task of consumer? So till now what we have done, the producer has written to the topic. Also, once the topic is written to the leader, the replica syncing is also done, and the followers is going to replicate the data to different disk space. Now since the data is persisted successfully in your system at a different disk space, the task of consumer comes to read it from that particular topic. So consumer reads from the leader partitions. Once it reads it, there are two important things the consumer has to do. Always remember these two important things the consumer always have to do, and you have to do it in your coding also. It acknowledges the broker that I have read your message successfully. And once the batch of messages are read successfully, you have to commit the offset, so that in case the consumer fails and when it comes back to the life, it cannot read from the starting offset from 0. It should not do that. Otherwise, you will keep on replicating your logs. You never see the logs in Splunk as this is the log coming at 11 o'clock. This is the log coming at 11 o'clock. This is the log coming at 11 o'clock. No, you don't do that. You don't see the duplication of data. What you see is 11 o'clock, 11:1, 11:2. This is how you see the data. So how do this is made sure by Kafka? This is made sure by Kafka using the offset commit, which is done by consumer whenever it has read some batch of data. Also, it is a task of leader to ensure the followers are kept in sync. Next is the fault tolerance. Now, so this was the read and write. I have told you the producer has written, the replica has been made, and consumer has read. But what if a leader broker dies and consumer has no leader to read from? So it's the task of zookeeper to quickly elect another leader from the ISR replicas, that is, who are in-sync replicas who are capable enough to become a leader. That is in-sync replicas. That's where the leader is decided and the consumer starts consuming from that particular different disk location, which is the follower now has become a leader. Also, Kafka makes sure about scalability, horizontal scalability. So if the thousands of logs are coming, so if some sale is going on, the multiple orders are coming, multiple emails are sent, multiple logs are coming, then what they do is they include multiple brokers, they include multiple partitions by increasing the disk space and increasing the number of partitions. Now, since the data actually stores into the partition, what is actually horizontally scaled is nothing but a partition. And since the partition is scaling, the multiple brokers who are followers will also have to scale. Now Zookeeper is the one who elects the leader, maintains the metadata, and helps in managing the overall state of Kafka cluster. So this architecture of Kafka helps you maintain complete durability. So if you have produced a message, even if your one Kafka server dies, you know that two servers are still awake who is having your data, and you can sleep in peace that yes, your data is not lost. Also, it is fault tolerant. If one of the leader dies, another ISR replica can become a leader. Scalability is also maintained at the partition level. It scales horizontally with the partition, also with the brokers. The real-time processing capability is also having with the Kafka because it has streaming capability, because you have offset management done by Kafka for you. So this dynamic and distributed nature of Kafka enables robust and reliable data streaming in various use cases. So that was all about the architecture, which is very important. I know it's very complicated because there's a cluster having multiple brokers having topics having partitions having offsets. It's very complicated. So understanding this architecture of Kafka is very important before you go for an interview for Kafka. Now they can ask you that, okay, you know this much about Kafka, but why did you actually use Kafka in your project? What was the need of this? So at first, I have already told you that suppose I have an e-commerce website. Now it has large volume of data coming during the sale. Then how do you handle it? So Kafka is very much scalable. What it does, it has partitions. Partitions are nothing but a disk space. So whenever there's large amount of data coming, then it will get some disk space from the cloud or from in-premise servers and appends the data in the disk server, thereby also making it fault tolerant by copied two different follower partitions and follower brokers, thereby maintaining two replica of one data that you push to your server. So that's the bare minimum requirement of Kafka, that if you have one broker, it is always good to have two replicas. Also, it is durable. What it is publish subscribe model. That means there is not going to be one consumer, there can be multiple consumers. That is why it makes sure that your data is not deleted as soon as you read it. It is going to live until the time to live or expiry doesn't count. So that is why it is durable enough, and multiple consumers can later on also subscribe and consume if the data is still under the expiry time. Also, it has real-time processing system. Why? Because the consumer do two things, acknowledgement and offset commit. Remember, these two things are very important. Now, since it acknowledges that I have read, also it commits its offset that I have read this much. Now the order is also maintained and duplication of data is also not done. So that is why it is very good for streaming. Also, there is partitioning of data, and since there are multiple partitions and data is written into multiple partitions, multiple parallel processing can be done for the same log using multiple consumer and consumer groups. Also, it is very high throughput because it is suitable for application which is having a large amount of data, like for example, having the logs for the time where your e-commerce website is having the sales. At that particular time where there is high throughput, then also Kafka is very good. Also, there is data retention policy. That means unless your data and time limit doesn't expire, there is a time to live still there, you have the data retention, the data will not be lost. Also, you have dynamic configuration, allowing the multiple topics and partitions to be added and removed without disrupting the entire system. You have dynamic reconfiguration that is actually done by Zookeeper. Whenever you have one of the broker dying, you can dynamically elect the new follower. That is dynamic reconfiguration of your topic and partitions. Also, since I've already told you, Kafka is now an open source project after 2011. It has a very vibrant community who actually contributes to its development. Even you can do it. It is widely adopted and used across multiple big MNCs also, like Goldman Sachs and many more companies use the Kafka. So it has a very big community and very good support. What is the role of Zookeeper in Kafka? So Zookeeper is the one who acts as the centralized and reliable coordinator for Kafka cluster. So what is the main component of complete Kafka architecture? That is Kafka cluster, because everything including broker, topic, partition, offset, everything exists in the cluster. So that is the main heart for the Kafka. Now, if that cluster dies, nothing is there. Who has to manage that particular cluster? The one who manages that complete cluster is Zookeeper for you. So that's why I say Kafka is nothing without Zookeeper. So different components inside Kafka cluster can work together and seamlessly only because of Zookeeper in place. It helps in managing the dynamic nature of Kafka cluster by providing fault tolerance and enabling coordination among different components. Also, how does it manage the fault tolerance? By managing multiple brokers as leader and followers. So even if the main leader broker dies, the follower can become a leader and is elected by zookeeper only. Also, there is very much worth noting point that Kafka 2.8.0, since then there has been efforts to reduce the dependency of Kafka on Zookeeper, because remember, we have to open two servers simultaneously, Kafka server and Zookeeper server. That is an overload and overhead. So after 2.8.0, now there are multiple efforts being done to reduce the dependency on Zookeeper. So with ongoing work to replace it with the self-managed metadata store, now it is said that after Kafka 4.x, it will be completely removed. Also with 3.x, this removal is still there, but it is not production ready, so you cannot use it. So I would suggest that either go with the 2.8 or earlier version, or either directly go to the 4x version where it will be completely removed. Remember, Kafka 4.x is not yet live till date. Now a very important question. What was the role of Zookeeper? If it is so important, what actually it does? So we have seen with a very high level overview that it does the leader election. Whenever the leader broker dies, the task is of Zookeeper to elect from the ISR, that is the capable followers who can become a leader. Also, what it does is it does the broker registration. So whenever a Kafka broker is added, it has to register itself with the Zookeeper, and also it has to keep in sync with the leader to become a capable enough leader whenever the leader dies. Also, it has the topic and partition information. Zookeeper stores the metadata about topic, partition, the location where the partition is actually hosted, and this metadata is very essential because it is the place where the actual read and write happens. The actual partition is the place where read and write happens. So Zookeeper is the one who gives the information that this is the leader broker and this is the disk space where the leader is actually writing. So this is the place where you have to write the data being a producer. So that information is also with the Zookeeper. Also, consumer group management is also done. I have already told you, if you have multiple consumers, they are actually grouped into multiple consumer groups. We'll be seeing in upcoming questions what are consumer groups. But Zookeeper helps in tracking the offset of each consumer within each partition, so that whenever the consumer dies, it can come back and do not read the duplicate data. So that management of offset management is also many times done by Zookeeper or the Kafka for you. Also, Zookeeper is the one who manages the health of Kafka brokers and topics. So as soon as it knows that yes, your broker has died, the next task of the Zookeeper is to elect another follower broker and make it the leader. So the leader health management and monitoring is also done by Zookeeper for you. Again, a very important question. Can we use Kafka without Zookeeper? But after 4.x, we know that Zookeeper is going to be removed and the dependency will be completely removed and it will be integrated in the Kafka itself. So yes, Kafka traditionally relied on Zookeeper for multiple coordination and management such as leader election, storage of metadata, offset management, broker discovery, health management of brokers and everything. That was done by Zookeeper. However, there have been development and efforts within the Kafka community to reduce or eliminate the dependency of Zookeeper completely. But till now it is not done. Starting with 2.8, yes, there are been tasks to remove the dependency of Zookeeper, and also with Kafka 3.x, there is an initiative called as KIP 500, that is Kafka Improvement Proposal. Because Kafka is too much tightly coupled with Zookeeper, there is improvement needed to remove that Zookeeper dependency. So this is Kafka Improvement Proposal that aims to make Kafka fully self-contained system who doesn't have tight coupling with Zookeeper at all. So after Kafka 4, there will be no need of Zookeeper and that will be the loosely coupled. Then only one server you have to start, that is the Kafka server. So yes, Zookeeper dependency removal is a very significant change and will be now internally a component of Kafka after Kafka 4.x. I have many more questions to cover, like the role of offset, what is leader, what is follower, multiple things I have to cover with Kafka. Just let me know in the comment section if you need more interview questions on Kafka. I'll create another video on the same. Thank you.